we're fine with the shift here, number 2. The shift was very easy to see because it went from being at 0, 0 to being at 0, 3. Dot, 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 dot. So how far did it shift? Up by? Yeah,
up by 3.
3.
So again, most of you guys did not have issues with that. When we were talking about just picking the thing up and moving it, that was not the issue. The issue seemed to be, again, with how could we tell what the vertical stretch or the horizontal stretch happened to be. Here's the way to tell. What is the slope of this line? Because this is what's going to be affected by the stretch compression. We have a slope of 1. Okay, obviously it's easier with the straight lines than the curvy lines. But here, if we're looking at the slope of the original function, that slope is 1. Those of you guys who have the paper in front of you, what is the slope of the new dotted line? And you can look at yours too.
Thank you.
And Mike, you can also look at yours too.
Oh, there.
Which one, this one?
Yes.
1/3. Really? I thought it was 1/2.
It's 1/2.
Oh, wrong answer. You seem so confident too. So
Yeah.
if we're counting again, it's just a straight line. We count our rise over our run. We go up 1, we go over 2. So how much did it change?
2.
And did it get flatter or?
Flatter.
It got flatter. So we could say it's a vertical compression, which means our A would be 1/2. That would be an acceptable answer when we're doing the equation.
Yes.
Or if you wanted to do the horizontal one, it would be a horizontal stretch by 2, which would mean we'd have a B value of 2. Either one would be perfectly fine.
Oh.
Okay, that's up to you. But this is how you, again, I'm not giving you these problems. I have not seen this be an IB problem where they give you the picture and they ask you to find it.
Wait.
It's either giving it to you in words or asking you to describe an equation in words.
Okay.
But this is how we would find them.
Is that why in number 8 it's 1/3 instead of 3 because they use compress? That's what I assumed.
And that's what I said, yeah, having it outside, it depends on them. Oh, no, that should, I told you, they're using the words differently than I
Yeah.
did, which is tough. You will hear different, mine's always vertical stretch, vertical compression. And that's how it should be, but you'll see different things.
Is it going to be like that on the IB?
We'll look at it for the practice ones. I'm pretty sure I'm using the IB language.
Wouldn't it be a vertical compression also, too?
Well,
So
you,
when he's
so you get
talking,
either
so
or.
he can see
You could
the
do
hand
either the
movement.
vertical compression.
He talks
I'm
like
calling
this
it
gets
1/2 because it translates to a 1/2 in the equation. But it is a compression by a factor of 2.
Okay.
But we would write a compression of 2. If I was writing this out, it'd be 1/2 out in front of the whole equation. But yeah, terminology-wise, vertical compression by 2 means the same thing.
Okay.
Oh, okay.
Other stuff on number 2, or if you want to look at some of the curvy graph ones, same
Yes.
idea, just obviously it's curvy.
Curvy.
When it says like by a factor of, that factor of will always be a whole number, it would never be a fraction.
I think on the homework they did always whole numbers. I'm fine saying it's a compression by 1/2. I'm comfortable saying that. I think they on CUDA software, this is not the IB stuff, when we threw the IB book in the garbage. I think they would always say it's a compression by a factor of 2. Yeah.
Okay.
I didn't see any fractions in the homework. Did you guys during that stuff? No. Yeah, so I think they always translated into whole numbers. Alright, was there a particular, a lot of people on the second page can do them. Is there a particular curvy one you want to look at? It's the same idea.
See, I can get a single one. So I don't want any.
Little mumbles.
I guess like
Oh, okay.
it's hard to distinguish. I feel.
They are. Like, they're very hard to see. I think that's one of the reasons IB doesn't put them on there, is because if you just can't see them, that's oh, 12 not curvy.
Oh. Okay, then.
But what? It has
12 would
like
be the
2
same idea. You find
lines.
the slope and the slope.
It's just weird to see the. I don't know. I couldn't understand.
Actually, the slopes are the same. They're both 1. So you just have a negative, you just have a flip. Alright, so anybody else got a curvy suggestion?
10.
10 looks nice and curvy, huh?
I mean, I wouldn't say nice, but.
Well, okay, well, sorry that that's some.
Alright, so 10 you've got cubics, or at least it certainly looks like a cubic.
Rule 16.
That goes like that. I would just count corner box to corner box. I don't like to deal with fractions in the graph because you can't tell. So we have it at 0, 0. What's the next corner that it hits?
1.
1, 1. Yeah. So we go from 0, 0 to 1, 1.
So the slope is 1.
Not really, but for our purposes, we wanted to say that, sure.
It's probably just X.
Alright, for the dotted curvy line, let's look in the middle. Where does the middle seem to hit?
0, -1.
0, -1. And where's the next thing it hits?
1 negative 2 -1.
I see
I
2,
mean,
0.
2, 0.
Okay, let's just say 2, 0. So here you go back. So let's look at those two slopes. The first one went over 1, up 1. Which, and again, I'll put m in quotes. It's not the actual slope, but it's how far the thing is moving. How far is this guy moving?
So,
Over how much? No. Over how much? 2 and up.
1.
So slope of 2. So what's our factor going to be?
1/2.
Well, some kind of factor of 2. And then we have to ask: is the thing getting skinnier or fatter?
Getting fatter.
It's getting fatter. So we could say vertical compression of 2. So we could have an a value of 1/2, or we could say that b equals 2. Either one of those would be fine. Which one does the answer key give it?
They give B.
B, B,
Or either or A. Whichever one's 1/2.
Okay, the 1/2 out in front, which is obviously fine. She's right in that classroom right there. I can hear you through the wall. I'm through the wall. I'm in your former room.
Or like, or, I mean, is it because the B is 1/2? Wouldn't it be B 2? Because it's stretching.
It should be a few. If I had the thing, we would just wrap it and see if it hit or not.
Get out the way.
Eroding the shot.
I would say B of 2, but again, yeah, God, again, please just don't sweat that. And I'll show you what the IB questions look like when we get back from break. There's nothing really to sweat yourself about. They're the easy like questions numbers 1 and 2, and they will be like, if you wanted this function to move up 1 and right 2, how would your equation look? And that's what they're expecting you to be able to do with this stuff. Except, of course, for the trig functions, which I told you for the trig functions, we're going to spend a whole week doing that unit, because then they do expect you to translate from the graph to the equation and stuff like that.
Wait, so you said they're going to be easy like 1 and 2, so we're gonna have to find out like the
Oh,
factors.
sorry, not like 1 and 2 in your homework.
Oh.
Remember on the IB exam, the earlier questions are easier and
Oh.
shorter? That's what I meant by 1 and 2.
So-
It'll be like the first 2 questions on your actual IB exam will be those, when they show up.
Do we have to know like what we did there, like with the slow finding the factors and stuff?
That's what I'm saying, I've not yet seen a picture of a graph
Oh.
that says describe the transformations. They'll give you an equation and say describe the transformations, or they'll give you the transformations and say write the new equation. I've not seen it from a picture.
Will they have us graph?
One more time?
Will they have us
No.
graph? No?
The only graphs are on day 2, and those just require you to type the equation into the calculator and hit a graph. There are no day 1 graphs, except for the trig functions, which, again, that's a later problem.
Oh, the wave things?
Wait, yeah, and we are going to have to get very specific with how to graph those in the meetings, though.
Last year.
Okay, so today's stuff, we'll see how far I can go. Again, this isn't like normal. Or actually, maybe it is normal. I'm just normal sick today. I have a cold and I feel terrible. But,
Sorry.
no, me too. But it's not like the diabetes one where I'm passing out on my face. So I'll go as long as I can go. When I start to feel super icky, I'll stop. I'd like to make it through at least arithmetic sequences and series today. We'll see. If you guys want to go further, I can just go make more copies of stuff too. But we'll see how that goes. You did these last year, like with almost everything we're doing. What do you guys remember about arithmetic sequences?
I'm.
It's like A1.
There is an A1 in there. Not just
Yeah,
mistakes.
isn't it like one is addition and the other one's multiplication?
Well, so when I say an arithmetic sequence, could one of you guys give me an example of an arithmetic sequence?
how
many
possibilities there are or something?
No,
Or like
that's the
adding.
binomial stuff.
2, 4, 6, 8, 10. Like
Mm.
that.
Yeah.
Yeah, and so how do we know that this is an arithmetic sequence?
Because it's by
Consistently increasing.
adding, it's by addition.
Or
Uh,
what's the other option other than addition?
Subtraction.
Yeah, so we can tell that each of the numbers, as we're going through the list of numbers, remember sequence, and this is the first part, sequence is just a list of numbers. You are not doing anything to the numbers, you are just literally listing the numbers in a sequence. And we can tell there's a mathematical way to write it too, and I'll write it. IB doesn't use A's, they use U's. Sorry if you got used to A's last year. But U n plus 1
Oh, wait.
minus
Oh, shit.
un equals e. This is the mathematical way of saying this is happening. We'll talk about what that means. What is that really saying?
What was D again?
D is difference or distance.
Oh, D.
So like,
Does it can also mean difference? You say
that,
difference?
Yeah, it's a difference or distance, absolutely.
it's just saying a number plus what I mean. The number, like, one above the number.
So let's say I picked 8.
Right.
8 minus which number?
It would be 8 minus 6.
Yeah, this is saying if I take any number and I subtract the number before it,
Mhm.
because remember, these are talking about the place in the system. So if I take the 5th number and I subtract the 4th number, I'm gonna get this number. If I take the 100th number minus the 99th number, I'm getting the exact same number. That's our definition for something being an arithmetic sequence. Whenever I take those two numbers that are next to each other and I subtract the bigger minus the smaller, I consistently get that same number. D is the number we use in the formula to describe, again, I've heard both different ways, either the distance between the numbers, which makes sense, is how far apart the numbers are, or the difference, because obviously we're subtracting. But that's our definition, that's how you can tell. It does have to be consistent. So when you see a sequence of numbers, please don't just try the first two. And they go, this minus this is this. You do have to make sure that for every number in the sequence that holds true. Because what's the other thing that we do see frequently that we're not adding or subtracting, we are...
Multiplying, dividing.
Yeah, so you have to make sure it's arithmetic. And then option C, they might give you one that's neither. So you do have to check every number in the sequence, make sure it's consistently adding or subtracting the same number, or consistently multiplying and dividing the same number. That's what makes it an arithmetic sequence. The good news is, we have a formula that's in the formula booklet that helps us calculate any term of an arithmetic sequence. Anybody got help for me? How do we find the nth term of an arithmetic sequence?
It's the first term,
Very nice. Let me give you a plus sign there.
and that's all I got.
Give him some help, he got far.
Oh,
N minus 1 times.
D.
Hey, there we go. Very nice. Alright, so there is our formula for finding any random term and an arithmetic sequence. So obviously in terms of variables, they can give you different amounts of variables. We have a total of 1, 2, 3, 4 variables in the problem. If they give you any 3 of these, you guys can solve that equation for the 4th one, and then it's just gonna require some, algebra skills to get the missing one. Let's try one of those real quick just to make sure that your brains are working and all that good stuff, and you'll try to see plenty more of those today. So find 100th term of 7, 4, 1, negative 2, dot, dot, dot. All in, and that'll give you 100.
Okay, I got the answer too.
Okay, well, you have Dylan. What do we got?
You got everything
Negative
else.
290.
You got
Negative
the numbers
290.
Yay! We have 2 negative 290s. So I'll let you guys finish up if you're finishing up.
Oh,
I'm gonna
Like
see-
that's the negative I was talking about. I didn't realize it was a -3. I just looked at it and said 3, and then I was like, oh wait, let me check that. It's
Yeah,
going
so be very
backwards.
careful. We're gonna have to deal with that when we get to geometric too, if it's being multiplied or fraction multiplied.
Mm.
Flipping
Things
line.
divided.
Okay.
If you're not getting negative 290, let me know. We'll take a peek. So let's say, I'm telling you it's arithmetic, they would have to do that. And we'll say the 5th is 572, and the 27th is 14. Find the 150th term. So before I just let you guys loose to try this, let's make sure we have strategies. What do we have? Which variables do we have?
We have UN.
We have un
And
and we have n. So what are we missing?
we don't have D or A1.
We don't have d and we don't have u1. Alright, if we're missing 2 variables, what's always our strategy in math?
Oh, system.
We need a system. So there's your strategy, guys. Build a system of equations for this. It will help you find your d, which is what you're going to need to do this problem. Alright, so anytime when you don't have enough information, just be aware. And I saw this all over the ACE exam, much more than I will on the MB exam, that they always want you to do a system. You see it occasionally here. So build that, I'll give you a couple minutes, and then we'll walk through those steps and make sure we can get there. If you do have an answer, let me know.
The whole
Thing.
thing
Alright.
is repeated.
Wait,
That seems about right.
I guess I did that wrong
That would be to find d, guys. Which part?
Well, find the.
Okay, so you okay setting up the system?
I don't. I just did
You could also
I
could
just did
subtract
20.
these and subtract these and divide, yes.
subtract. No, I just.
Oh, you. Wow. So Yeah, I did that. Wow, I did this.
We're gonna pause here. This is not the answer to the question. We still have to find the 150th
Wait,
term.
what number is that? They write to 70, we'll get it wrong. With
If they said
70.0.
specifically rounded 3/6, yes, you would want the 70.0.
If
If
in the wrong category.
if it's a question where they don't necessarily state to put three significant figures, but I get an answer like 105.4 exactly, would it still be allowed for me to put three significant figures?
Exact answer is always great. Full calculator is always great. It's if you choose to round. Like, keep trying to tell you guys this all. Please just round. I know it's easier to not write the extra numbers, but if you choose to round, it has to be to three significant. They won't take any other rounded answer.
Okay.
Any other answer though is always great. They don't expect the rounding. It's an if.
So there's no like rule at the beginning of the test where it says every answer must be rounded to 2
No, the only time I've seen it, occasionally on literally question one of the exam, they'll give you just some numbers and say, please round the following, and they won't even say 3. It'll be like, please round to 5 sig figs, please round it just to test rounding. That's not an every year thing, but I've seen it as question number 1 a few times. But outside of that, no, it'll just assume that you are aware that if you're rounding, it won't even say in the directions. I don't think it doesn't say round to 3 sig figs.
It would say like.
Yeah, I don't think this one does. It's been a while since I've looked at the directions, but because I obviously don't read it to you guys since I'm nowhere near the room.
Yeah.
But I'm pretty sure it doesn't even tell you that. That's just the thing you're supposed to know. Alright, that's sequences. Yay!
I got 3110. I mean 3105. Okay.
Oh, yeah, we rounded to 3 sig figs. So let's do series. If we get through series, I'll give you some time to practice. We'll go from there. Okay. What's the difference? That's geometric.
Yeah,
series.
I can see that.
What is a arithmetic series?
Your mom is so
My
awesome.
mom is not a geometrician.
No, my mom just texted me, by your school, do you want to
Wanna
leave early?
Say yes, I've got your homework.
I'll say wait a couple minutes till after series.
Oh, there you go.
Wait, like,
Jolie, just go.
just go.
Alright, so the difference. Instead of listing a bunch of numbers out, what am I doing with them? Very nice. So the numbers will still look just like the arithmetic sequence did. The numbers themselves will still follow a pattern.
Thank you.
Where they either go up or down by the same amount. So if we took the plus signs out, this would still be an arithmetic sequence. The difference is in the series, we're actually adding the numbers together. So again, you can still identify the pattern in the numbers the same way. We know that this is arithmetic because the numbers go up by 2 every time. But the series is going to ask us to add them all together. Again, you just get a formula for this stuff, and you're given the formula in notes. Should I even ask? Because it seems like we're unaware, but I'll give you the shot. And we got the formula for the series?
I have the.
I'm going to write it as this. I'll show you the other way to write it too. Sadly, no. Remember, we're adding them. So instead of this number being 10, this number will be 12, 20, 30.
First term.
So it can't be the same.
Is it first term?
First term is in there?
Times.
Nope. I'll give you that one. We got first term. Plus, good.
Mhm.
Oh, it's up parentheses.
Oh,
I don't know how to make my parentheses less C-like. They're all going to be like C's.
D.
I'm
No D's, go fish.
R.
Okay.
No R's, go fish, no K's. There's an N. Put it in the fractions.
One.
Oh, no, it was like n over 2.
You got one more thing left to fill in. We're getting so close. The man would not be hanged yet at all.
U
Not one, sadly.
plus,
Stop saying one.
There are letters in it. There's 2 letters in it.
is it UN?
UN! We have a winner, alright. So, again, I can explain where the formula comes from. I don't really care. You get the formula booklet. They give you a second formula in the formula booklet. It is the exact same as this formula. The difference is they take UN out and they replace it with the formula we just did for UN. So they do U1 again plus n minus 1 times D. I think they actually even combine the 2 U1s together.
That's the one I remember from
Yeah,
last
so it's
year.
both.
What
Mhm.
is that?
Where? Tell me where.
SM?
S of n.
What does that mean?
The sum of the first, whatever n happens to be, so the sum of the first 20 or 30 or 40 terms. If you're given all the information, this formula is obviously much easier. Okay, you don't have to do as much work. So if you're given, let's count the variables, 1, 2, 3, 4. If you're given 3 of those 4 variables, this is the better formula to use. If you're given less information, like for example, you were not giving UN, then this formula will be easier to use. But again, all that would happen, you would have to plug in to get this one.
Why does it, that was a UN plus U1 plus U1?
Because that's what it is. I think they actually abbreviated again in the formula booklet as 2U1.
So I was switching those.
No, there were actually 2U1s there. So again, use the one that's easier for you, depending on the problem. You can only use one formula forever, you'd be fine. It's not like you have to switch back and forth, but sometimes one is easier than the other one. The other one that I don't know if you guys are as familiar with, how much did you do the big capital E's last year?
Wait,
Okay, awesome. That's like my last
which
line
E?
here.
Summations.
Yeah.
Oh.
This is the other way to write this. So I just want to make sure you're familiar with the terminology. This is how your calculator will do these for you. Obviously, we don't have the calculators today, so we'll practice with those when we get back. The calculators will do the summation work for you. So if this is on day 2, a lot of this stuff can be solved for you as long as you're comfortable using the sigmas. These are capital sigmas. Alright, so let's go ahead and try to write this formula out. What is the first term of this formula? What's the first term? 2. Good job. And then what's the
I shook up on that for a second.
2 and minus 1. Okay? And if we wanted to add all of these numbers together, we just have to figure out now how to write a formula that would make us add these numbers together. What's the first number? This is u sub what?
1.
U sub 1. So the first number I want to plug in for n is 1.
Mm-hmm.
That's what the bottom of the sigma tells you. The bottom of the sigma is always going to tell you where you would like to start. I will tell you 99% of the time you're going to want to start with the first term. Obviously, if the problem said, what is the sum of the 5th through 100th terms, well, then you would want to start with the 5th term. But for the most part, you're going to be starting with the first term. On top of the sigma is going to tell you where you want to end. How many terms do we have up here? 5. 1, 2, 3, 4, 5. If I type this in the calculator, it will give me the sum of these 5 numbers right here. Okay? So you're going to get a chance to practice with this sum today. Obviously, this works when there's way more numbers. For these 5 numbers, I would hope you just add them together. I didn't hear it through the yawn. This is not a formula. This is the way you're going to type it in the calculator if you want to use the calculator to solve these instead of doing it by hand.
You're also like a sum of infinity or something.
We are not near, well, I say we're not near there. We're like 2 days away from there. But not with arithmetic ones. Those are only going to be with our geometric ones, which we haven't talked about yet. But there is a way to add an infinite number of geometric.
Are we
terms.
doing geometric today?
I was not planning on it.
Okay.
I figured this is enough for 1 day of stuff. And because we didn't have a quiz, you'll actually probably finish the homework in class. And over Thanksgiving, your only homework will be
Math.
Math, hooray! Which is still due the Sunday of Thanksgiving that you guys voted on. So not this Sunday, but next Sunday. No, the research part.
Thank goodness.
Oh.
Yeah.
Just the research
Oh,
part.
so did you like?
No
Okay.
math.
I responded.
I did.
Oh, I love it. I think you're gonna have to leave
I don't know.
Spotify on for a long time just to get data.
Sort of.
We're
How
doing
many-
on
How many
homework.
things you can
Why
use.
in your throat?